So, welcome. My name is Kristian Salo, and I'm the technical guy from SimpliVity. And today, in the next 45 minutes, I will do a short introduction who we are, who is SimpliVity, where we come from. We'll go through what we are doing and why we are doing, and then we will go through how we are doing that. For example, how on earth can we recover a 5 terabyte virtual machine from another data center to another in about 5 seconds. I will also show in the demo when we recover about 70 gigabyte virtual machine from the Amazon cloud in about 5 to 10 seconds. And that's a 1 megabit line. So, okay, now I have to smile. Sorry about that. So let's go to the actual agenda. In the end, I will show a demo. It will be a bit of short demo what we can do, but I will be also in the Atea booth over there. It's actually right behind this wall. So if you want to see and ask more questions after the presentation, I will be there for the whole afternoon. So okay, let's go to the agenda. So SimpliVity, the company was founded in 2009 by a person called Doron Kempel. And Doron Kempel was a guy who, in the early 2000s, founded a company called Diligent. And Diligent was a company who made deduplicating backup appliances, like storage systems meant for backup and archiving. And he sold that company to IBM in the middle of like 2004, 2005. So a few years later, they sat down with some engineers that he gathered from VMware, Dell, IBM, EMC, Oracle, and NetApp, and they started to think about what is the kind of underlying problem we have in modern data centers, especially in virtualized data centers. What is the kind of core problem that needs to be solved to be able to work in the modern times where you have a huge amounts of data? So they spent about 3.5 years to build the product. So that's actually, if you think about startups, normally these investors, when they talk about investing into a company, they would like to have a product in the markets in 12 to 18 months. So Doron Kempel was using a lot of his, the capital he received from the Diligent when he sold that to IBM, and also the kind of problem that we are solving with the Omnicubes, the SimpliVity Omnicubes, was such a cool thing that all these investors were pretty okay with the fact that we made a product that is ready for the market, and that took, it's not simple to do that, so it took a few years. And these are the same investors that years ago invested in companies like Google and Amazon when they started. So they have a pretty good track record seeing good companies. So 3.5 years in development, and when we came out with the product in late 2012, already in the first year we won the VMware Gold Award for Best Storage and Backup product. SimpliVity Omnicube is a hyperconverged architecture. What it means is that we basically bring all the functionality of the legacy stack where you have servers, storage, backup appliances, and all those things in your rack. We bring all the functionality into this single building block that when you need more capacity, you just add those to the rack. So one of the functionalities of the Omnicube or the OmniStack is backup. And we actually won the best backup product with the whole hyperconverged architecture against the big guys like Symantec and EMC and HP and etc. So even though it is an all-in-one product with all the functionalities, the individual functionalities or features are really best in class. So another nice award was the best infrastructure product, but enough of the awards. I think more important ones are the actual customer references that we have globally. One of the biggest ones in Europe is T-Systems, that is a Czech operator they have built their private and public cloud in 3 data centers with Omnicubes. In Estonia, our first reference was Tallinn Technical University that is using Omnicubes, and we also have one guy here in the one very happy customer that I'm not sure if I can tell the name of the company, but he came with the user interface and showed me how well everything is working, and they actually won in their internal race. It's a global company, and they have this application. So they have an internal race who runs the database query fastest. And the Estonian guy beat all the Swiss guys and other guys in the world with the Omnicube solution. So it was 3 seconds faster than the legacy stack thing that they had in Switzerland, which was cool. I heard that today, so I'm happy about that. So another, as a technical guy, I'm a geek, and I enjoy technical challenges. One of the interesting ones is Petrobras, which is one of the top 5 oil companies, a Brazilian company. And what they do is they have these drilling ships or drilling stations in the Caribbean Ocean, and they have these ships that go to the drilling stations and gather the oil from there. And inside those ships, they used to have a VMware data center, like a rack full of stuff, storage and servers and everything. Then the problem that they had was that how to back that up, how to back the whole rack full of stuff to the central data center in Dallas. So what they did earlier was that when the ship comes to the shore and when they dock, they put the cables in and do the backups, but that was like every 3 months. So what they now have is that inside those ships they have 2 Omnicubes, an HA cluster, 4 rack units, like a really simple. That's a whole VMware data center. And they are able to back up daily full backups of those virtual machines over a 2 megabit line over a satellite to the data center in Dallas. That's pretty cool. So if you want to hear more about that case, come talk to me later. And some other interesting references here. So let's talk about the problem that our engineering started to work on in 2009 when the company was founded. They kind of looked at the data center, especially the virtualized data center, and found out that the main cause of all the issue, or most of the issues that you have in virtual centers is I/O and the amount of data. Probably today, when you see all the other presentations, all the IT companies have this presentation, this slide where they say that, okay, next year you have more data. What a surprise. So I have never seen a customer, well, actually once I have seen a customer who said that next year I will have less data. And that was a company, that company actually was split into 2 companies, so half of the data center went somewhere else. So usually it's more. So where does this problem come, or why is this a problem that we have more data? The way we store, or way we have used to store data is with spinning disks. And if we think about like 10 years in the history, when we had those storage systems had 36 gigabyte disks. I have gray hair, so I remember that. So 36 gigabyte disks, and those disks were able to provide about 180 IOPSes. That was the performance you could get from a single disk. Today, you can get 3, 4, even 6 terabyte disks. And how much IOPS we get from a 6 terabyte disks? Okay, I'll answer. About 150 IOPSes. So you have a situation where 10 years ago, when you had 36 gigabyte disks, it was like drinking from a water glass with a straw, like this. Today, you still have that same straw, but you are drinking from a swimming pool. So it's starting to be a little bit difficult. So this has caused a lot of kind of solutions in the market, but not really good answers. So we'll look into that, so stay tuned. So if we think about data center in general, there are other functionalities and abilities that it must provide. One of the first ones, of course, is performance. It has to be able to bring the IOPSes, the performance, to those applications. That's why I was really happy to hear from that one customer that they had the fastest system on the whole organization here in Estonia. the protection, you have to be able to back up and recover those virtual machines and your data really, really fast. Just before I started my presentation, I recovered a 5 terabyte virtual machine in about 5 seconds. Mobility, I'm not talking about mobile phones, but I'm talking about mobility of the virtual machines for protection, how to move those between data centers, and also for things like development, software development, where you want to take a clone of your production system and then move it to another data center for some development guys to work on. Of course, the fourth, the capacity, that's a no-brainer. You need to have a system that is able to handle all the capacity requirements. And last but not least, the management. If you think about a modern data center, you have your servers, you have your storage, you have your switches, you have your backup, you have your one accelerator stuff, you have your VMware console, etc., etc. The management starts to look like this a bit. There's this guy who has to work with, or several guys in many cases, who has to work with your server, storage, VMware, backups, network, etc. Maybe not 7 monitors, but 7 different user interfaces anyway. And the data centers, in many cases, one of my customers said that looks actually really, really nice. They had, when we went to their room, the cables were going like this all over, and I was like, oh my god. So it's starting to be a problem. So how did we end up here? So if we look years back when we still had physical servers, things were pretty simple. We had an application running on top of an operating system. It had CPU, memory, and storage resources. But the problem here was that, let's say this storage was starting to be full, and this had plenty of space. There was no way to kind of give the resources from another server to another server. So then came companies like EMC, where I used to work for 9 years. So I didn't tell my background, but who cares? Then came companies like EMC, NetApp, HDS, and came with this great idea that let's have a consolidated storage with a pool of storage that we can then give to all those servers. Great idea. That solved one of the problems. A few years later, the virtualization companies like VMware came with the same idea for CPU and memory resources. Let's have these powerful servers, put a hypervisor on top of that, and run our physical servers as virtual machines. Cool. Now we have a nice solution where we have a pool of CPUs, pool of memory, and pool of storage that we can give all to those virtual machines. And then we might want to, let's say that this is my data center 1, I might want to replicate it to another one for protection. Pretty simple, isn't it? And this is the high-level picture of many data centers today. You have your servers, you have your storage pools, and you share those resources. So, what's the problem here? Well, you don't see the problem that well if you only have like 10 gigabytes of production data. But when you throw the data problem on top of that, like 10 terabytes, 20 terabytes, 50, 100 terabytes, even more and more and more, you start to kind of see problems in different areas of the stack. So let's start from the big bottom. Let's say that your production data is here and you're replicating it to the other side. With the little data it's easy, but when you start to have a lot of data, it starts to be a problem. So that gave birth to companies like, for example, Riverbed, who make really, really great products for one acceleration. Awesome stuff. It's like magic what they can do. But their idea was that we have a problem, I can't replicate data to the other side. They built a solution for that one. The next problem, the backup guys. Let's say I have 10 terabytes data here. If I use the old school tape, from 10 terabytes of production data, I take half a year backup rotation. 4 fulls for weekly fulls first month, and 5 full backups for monthlies. That's 9 times the full, plus increments. So 10 terabytes of data in the tape, that's 100 terabytes. If you have 100 here, that's petabyte. So that again, some guys saw that, here's a business possibility to build awesome products like data domain and quantum and those deduplicating backup appliances. Again, really, really nice solution for solving that problem. Some companies say that, okay, there's this public cloud, I want to back up there. Again, companies were born to build cloud and bought the cloud gateway in there. The I/O problem, the straw drinking from the swimming pool thing, SSDs came to the market. So if you think about how to get the IOPSs, the performance, some companies see that, okay, a good solution, which it is to have an SSD array or an SSD cache, so your hot data is there. Or some companies say that the best place for SSD or storage in general is the internal storage of the server, so they put PCI cards in there to get the hottest data there. Or the storage guys, of course, said that, well, we can have SSD also. And then you put your software on top of that. It's not that simple anymore. All of a sudden, you have a huge amount of boxes and user interfaces solving different areas of problems. And when you throw more data, the answer from the industry has been that let's throw more stuff to the rack. And nobody kind of took a few steps back and, well, what's the core problem here? And the core problem is I/O. It is the amount of data that we have to move around the whole stack. Let's think about the life of that virtual machine. Let's say that that's a 100 gigabyte virtual machine. It lives on the storage. Maybe the hot blocks go to here, or here, or here, or here, depending on what's your solution. When you replicate that, the changes from that 100 gigabyte goes here, and the CPUs are running red here, doing compression and deduplication, sending it here, uncompressing it here, putting it to this storage system. When you do, let's say it's a database, you do a full backup, you read the whole 100 gigabytes to a proxy machine here, it pushes to the backup media and it gets deduplicated, etc. So the daily life of a virtual machine is a huge amount of I/O going through the whole stack all over. And you have to size your whole system because of all this traffic going everywhere. And the reason for that is that because nobody took a few steps back and tried to see what's the core problem. Everybody was just fixing spot problems here with different kinds of boxes. And that makes things complicated. So your typical virtualized data center today looks like, in many cases like this, that you have your servers. They can be this way or this way if they are blades. And then you have your storage with maybe SAN or IPs with your high available storage. You may have SSD, backup appliances, one optimization, cloud-grade storage caching, etc., etc. Not all data centers have all of these, but most of them have most of these. So the problem is that there's a lot of complexity, you understand? So too many boxes, too many screens, too many IOPSs, this is the big problem there. Too many refresh cycles. Let's say that you have to refresh your storage to a new version, and then you take this amount of compatibility matrices and start to check that, okay, this new version, does it support those HBA cards? Oh, I have to upgrade the microcode. Does that support our backup system? Oh, I have to upgrade the backup to a new version, etc., etc. You all know this. But this is something I used to work when I was at TMC. This was normal. This was what we were living with. It was like, if I have a problem with my knee, after 10 years, I think it's normal to go like this. I don't understand it is a problem, but if we think about it, that's a huge issue, and we have to do something about it. So the industry knows this is a problem. So about 4 or 5 years ago, the industry started to talk about converged infrastructures. So if here we have the legacy stack where we kind of the best of breed approach, where you buy your servers from there and you buy your storage from there and backup from there and one accelerators from there, And then if you have really skilled guys who have no other life, that you might have time to integrate everything really well. It is not a bad solution. It's just complicated and needs a lot of know-how and a lot of time to operate. And if you have a lot of money to spend into that. So kind of the first step to make this more simple was these integrated systems where companies like EMC, NetApp, Cisco and VMware took a really good step trying to make this simple, and these like vBlocks and FlexPods and things like that, where you take the servers, you take the switches, and you take the storage and pre-integrate those at the factory. So you have a rack full of stuff that comes from the factory that was pre-integrated. So you as an organization don't have to do this integration. It's a kind of a step to the right direction, but it's still same old legacy stuff, just in a nice package. So you haven't done anything to the I/O problem. The virtual machine is still moving around the whole stack, and you left out a lot of basic functionalities that you need for enterprise computing, like backups, etc. I was the backup guy for EMC with Networker, Data Domain, Avamar for 8 years, and I remember when vBlock came, it took about 2 years for them to come with the white paper how to back up the vBlock. The answer was that just back it up like you did before. But now they have nice white papers, but still the white paper says that buy a Data Domain and Avamar, a few other boxes to the rack. So the first like a real converged infrastructure is the way Amazon and Facebook and Google and those companies are building their data centers. They don't have these centralized storage systems. They are using x86 servers and using the internal disks of those x86 servers and build a virtual storage out of those. This is, again, a really great step to the right direction, like the announcement from VMware with Evorail, great stuff. So where you use just x86 servers and use the internal disks to build virtual storage over that cluster. But again, a lot of the functionalities what you need, like backups and disaster recovery and solving the I/O problem, is still missing from there. So what SimpliVity does and what Omnicube do is we take the whole functionality, the server resources, the storage resources, the performance of the SSDs, the backup capabilities, the backup software capabilities, everything in the legacy stack, and put it into this one kind of a building block, what we call an Omnicube. So with one you get all the functionalities, with two you get HA storage, with three you get scale out. So, and 4, 5, etc., etc. So it's a really easy way of building your data center, and a high performance one also. So we add basically to the enterprise capabilities, and this is the marketing guys' bubbles, what you understand. So let's bring the Omnicube to, let's go back to this picture and bring the Omnicube here. So as I said, Omnicube is a hyperconverged architecture. It brings all the functionalities of the legacy stack. And one of the functionalities, and here comes a lot of hype words in a row, one of the functionalities that it is an inline deduplicating scale-out storage. Nice word. What does that mean? Inline deduplicating means that everything we write to the storage on the Omnicube gets deduplicated, compressed, and optimized when it's born. We don't write anything to the disk unless it is a unique deduplicated 8K block. I'll explain this like really well a bit later. So everything gets deduplicated, compressed, and optimized when it's born, inline, like in flight. And scale out means that if you need more capacity, you just add more Omnicubes. So in other words, we don't need the legacy storage systems. Everything gets deduplicated, so when we do remote backups, remote clones, disaster recovery, stuff like that, we only move deduplicated blocks between the sites, so we can do stuff like backing up those oil tankers over a satellite to the Dallas data center. So we don't need WAN optimization. Just to clarify, and I like my friends at the Riverbed, those things do a lot other things like application acceleration and stuff like that. We don't do that, so there's still some business for those guys. So the backup is an internal functionality. We won the best backup product in 2013 in VMworld. So backup, we don't know those applications. Everything gets deduplicated and compressed. And also, we don't need any backup software because it's part of the functionalities. Cloud gateway, we can back up to Amazon and recover from there. So we have a public cloud integration. And we have SSD, so we get a lot of performance. One of those Omnicubes can one box can produce about 20 to 35,000 IOPSes. So if you need more, you just add more. And the scalability is about linear. And we are, it is a scale out, so when you need more capacity, you just put more boxes into the data center. And the ESXi is pre-installed, so you run your virtual machines on top of the Omnicubes. So your data center just got a little bit more simple. So what we can do, we actually have physical Omnicubes on this, just behind this wall on the Atea stand, so you can come and see those. When I can build a data center, if I have IP addresses and all the information, I can build a full 2 data center VMware data center with backups, policies, disaster recovery and everything in about 4 or 5 hours. And if you compare that to the legacy way, that usually takes a bit longer, this is a really, really simple way of building stuff. Again, the marketing bubbles. So, let's go and see how we do this. How is it possible to back up virtual machines like 5 terabytes in just seconds and clone and move and etc. As I explained earlier, Omnicube, this is the Omnicube, it's an x86 based server. So it has all the basic components, spinning disk, SSD, memory, and CPUs. On top of that, we have ESXi. And just to let you know, the actual hardware, we have an OEM agreement. So the server hardware that we are using, we have an OEM agreement with Dell. So that box is actually, the frame is R720XD frame. So we built on top of those. So if you have a problem, you open a support ticket to us. If it's a software problem, our 24/7 guys will fix that. If it's a hardware problem, we will dispatch that to the global Dell support, and some guy will come and fix the disk or change the disk. We also have a cooperation with Cisco. So if you are a Cisco UCS user, we announced in VMworld a few weeks ago the OmniStack, SimpliVity OmniStack for Cisco UCS. So if you are a Cisco user, come and talk with me. I'll explain what that means later. So let's go back to the presentation. So we have this basic x86 based hardware in the bottom, and then we put the ESXi on top of that. Between here, we have, and this is the important stuff, and this is the thing that we do and nobody else can do. So pay attention, please. So the data virtualization platform, in the heart of the platform here, we have what we call an Omnicube accelerator. And this is the stuff that the guys were building like 3.5 years. So this has a custom ASICs chip that is built for deduplicating and compressing and optimizing data almost wire speed. So everything we write to the stack gets deduplicated and compressed, and we only write deduplicated blocks to the physical disk. So let's keep in mind that this is the heavy lifter, the engine that is doing the work. We could do deduplication with these CPUs, but you probably know that these CPUs are used somewhere else, like running the virtual machines. So this is actually why there are other hyperconverged infrastructure companies in the world than SimpliVity. The other guys are not doing inline deduplication. This is why they do post-process deduplication. Because deduplication is heavy work. And if, let's say I have that 100 gigabyte virtual machine here, and I do a post-process deduplication, what does that mean? It means that the 100 gigabyte gets written to the physical disk, and then maybe at night time, like 6 hours later, all that 100 gigabytes gets read to the CPUs here, and you do deduplication, and then you write the deduplicated blocks back to the disk. So with post-process deduplication, you almost get like 3 times the I/O. Any NetApp users here? Have you tried the NetApp deduplication? Yes. You know it's pretty heavy when it does that in the night time. It's like CPUs are 100%. Yeah, you agree? Yes. Yes. So that's post-process deduplication. So you don't want to do that on the CPUs that you are using to run your virtual machines. That's why we have this really high-performance engine doing the deduplication inline. So what does that mean? This software layer, the data virtualization layer, we divide that into 2 layers. We have the presentation layer and the data management layer. The presentation layer looks like storage to the ESXi. This is the virtual storage that get from the whole cluster of Omnicubes. And it looks like a normal storage to the ESXi. The data management layer is where we do the magic. So let's say I have a write from this virtual machine. So it writes to the VMDK file in the presentation layer. So all the data, of course, gets registered to the virtualization platform, to the storage. So it's a change to the VMDK file. What happens in the data management layer is that we check that, do we have this 8K block physically on my disk? If we don't, we compress it and write it to the disk. Again, I get a new unique block. Do I have it here? No, I have compressed it and put it to the disk. And same thing here, I get a new unique write, it gets registered to the VMDK file, but here on the data management layer, I check that, do I have it here? I don't. I compress it, write it to the disk. Then I get a new unique block for this server. So it gets registered here, but here in the data management layer, we see that, oh, I already have that. I have received that block from somewhere else before. So I don't have to do a physical write to the disk. I just mark that as a pointer to this metadata of this virtual machine, that this physical block belongs to this and this. Same here, I get the duplicate block. We just add a pointer to the metadata. I don't do a physical I/O at all. I just point to this block. So it says here, the best I/O is the one you don't have to do. Which is pretty smart in a way. So when the system is running, what happens is that all these virtual machines are writing full speed to the data virtualization layer, but we only do physical writes in a case that any of those virtual machines has managed to generate an 8K block that we have not received from anywhere else in the cluster before. So this makes the write performance really, really fast, because when we hit the card, we decide it's not there, it's already there, we acknowledge it's written. And when we have 2 nodes, Omnicubes, a HA cluster, even if we lose one of those cards, we still have full access to the storage. So it is a really high available system. If you want to see the whole I/O path stuff, come to the booth, I'll explain. So what does this give us? So just to make the point clear, this deduplicated block actually belongs to all these virtual machines in many places. So the idea is to go from this, where you have all these different boxes and a lot of I/O going between all the components, to this hyperconverged architecture, and this is the important thing. Omnicube, SimpliVity Omnicube is the only one who does the data virtualization platform. So in other words, the virtual machine actually is just metadata pointing to the deduplicated blocks. Just a second. I just realized that. I hit that one. So the virtual machine here is just, as I said, metadata. This is the VMDK file. This is the metadata pointing to those deduplicated blocks. So let's add another data center here to this federation. So I have one cluster here, one cluster here. So if I want to do a local backup, what I do is just copy the metadata. I did not do any physical I/O. And I can do backup like every 10 minutes because I am not doing any full backups, like any full I/O. Same thing if I do a remote backup, I just copy the metadata there and I'm not doing any full like real I/O. I'm just checking which blocks are here and use those for those recoveries. When I do a full, if some of those blocks are missing, then I just send those to the other side. So I usually use Legos as an analogy. Let's say that this is a Lego racing car here. The metadata here is the instruction book, what Legos and which order I need to build that. And then I have a bucket of Legos here. If I want to do a backup of that Lego racing car, I just set the instruction book here and check what Legos I have here. And if I miss some, I'll send that to the other side. Clear? Okay, so let's have a really short and fast demo what we can do here. I will use a few minutes more because I started later. And my hobby is wrestling, so you can try to get me away from here. So here I have a 5 terabyte virtual machine. And in the beginning, let's first do a full clone of that virtual machine. So I'll just go here and do a clone virtual machine. And what I do in the background, I don't do any actual I/O. You can see that the cloning started. I just copy the metadata in the data management layer and then present it to the VM center. So now the clone is actually done already when we hit 33, and now we just register it here. Oh, it's here already. It was faster. So I just did a full 5 terabyte clone of a virtual machine. Let's move this virtual machine to another data center. So I have 2 data centers here, the San Jose, and I have the Boston one here on the upper area. So let's take this clone that I just did and move it to another data center. So I choose which data center I want to put it, to San Jose, the lower one here, and then I put more. Answer yes. So the move will begin, and what happens in the background, again, the metadata gets shipped to the San Jose data center. It will check the Lego bucket there and what Legos I have there, Legos, 8K blocks, and then it will use those, and only send the unique blocks that I don't have on the other side, if necessary. If this other side would be totally full, no Legos, we could trick it in a way that install an empty 2012 to get some basic Legos there. And then the first backup of that actual virtual machine would be, now you saw that my machine was removed, it's here. So that was a 5 terabyte move of a virtual machine between 2 data centers. The last demo I want to show you is, I have this virtual machine, not that one, this one, that is actually backed up to a public cloud, Amazon East. So it is a let's take an older backup here and recover that one. And again, this is a 1 megabit line from Amazon. And I recover it to Boston, restore it, press yes. And again, you will see soon that here in the task window, the recovery will stop. Oh, that was faster than, yeah, it's done. So it will now appear here. I have a 70 gigabyte full virtual machine restored from the Amazon. It's really fast stuff. So, and makes things like cloning, moving, etc. When I create data stores, everything is here. If I want to, I don't have to know anything about storage. If I want to do a data store, it's here. I'll build a new data store, I resize it, etc., from here. Everything is really easy. The last thing I'll show about the deduplication. Here I have local, all these virtual machines, it's 19 terabytes. Local backups, almost a petabyte, 700 terabytes, because of the deduplication. I have a really, really good deduplication ratio. Of course, this is a demo system. The customer who was here today, they had about 1 to 27 in production, which is good also. So physically, even though I have logically, I have data stored about 770 terabytes, physically I have used about 8 terabytes. Because we deduplicate, compress everything. And if I clone a 5 terabyte virtual machine from here, it is a full virtual machine when it comes here, but it doesn't actually take almost nothing in the capacity. You can see it is 5 terabytes here, 10 terabytes for the virtual machine size. And if I go back, we have it here. You can see it is a 5 terabyte, totally new, high-performant virtual machine. I'll go back to this slide. This went up, the logical, but physically, no change, still about 8 terabytes. Everything is deduplicated and compressed in the background. So, I think I'm like way over my time, sorry about that. If you want to see and hear more, I will be there at the Atea stand right behind this wall. So come and ask. We have a competition where you can win this quadrocopter thing. It's in the stand, and we will do the raffle this afternoon. So come there, talk to us, and ask questions at the stand. Thank you for your interest in the subject.